So we'll have an internal circuit diagram of this, which is important, and we have to explain the operation of IC 555 as a monostable multivibrator and as an astable multivibrator. This is the first portion of this. You deals with PLL. PLL stands for phase locked loop. We will discuss this in details, and this is generally used for a tracking mechanism. If we want to lock a particular frequency, we can make use of the tracking mechanism of the phase lock loop. So if we look into the phase lock loop, one of the sections of phase lock loop, it includes the first block is a phase comparator. The second block is a low pass filter. Phase comparator is also called as phase detector. And third and the last block of this is a VCO. So VCO stands for voltage controlled oscillator. Am I audible to all of you? So
yes sir, yes sir.
So what are we going to study? In the first section we have to study IC 555. In the second section of this unit we have to study phase lock loop and its applications. And in phase comparators we will have to study various types of phase comparators such as XOR, monolithic, etc. So this question is asked in the exams. What are the various types of phase comparator circuits you have to discuss? And as I have already told you, the chip number of PLL is IC 565. This question is asked in the exams. And as far as voltage controlled oscillator VCO IC is concerned, the chip number is IC 566, right? So we have to cover IC 555 and we have to cover PLL, and this is quite scoring section of this subject. Now, what are the various applications where we can put IC 555 as a chip? We can make use of IC 555 in various circuits. So first of all, let us explore the possibilities or applications of this chip and why this chip is used. The most important factor is that this chip produces accurate time delays. Right, so that's why we call this as a timer. You would have seen in the traffic lights, we have accurate time delays. So we have the sequence of red light followed by green light, then followed by orange light and again red light. The accuracy of these junction lights is so high, it is just because of the use of timer IC, which produces accurate time delays. And now some of the applications where we can make use of IC 555. One of the applications I have elaborated just now. So we can make use of this as a monostable multivibrator. We have understood the meaning of monostable multivibrator, a circuit which is excited. The trigger is stable multivibrator. Then we can have DC to DC converter, or we can call it DC transformer, which is also called as a chopper sometimes. So in DC also we can have step up transformer and step down transformer, just like in case of AC also we have a transformer. Then we can make use of this in the generation of waveforms, so it can be used as a waveform generator. So in the default mode, it produces a rectangular waveform. So in the default or in the normal mode, it produces a rectangular waveform such as this, and we can convert this into a square waveform. A square waveform has a duty cycle of 50%, as I have told you, because in case of square waveform, time interval t1 and t2 are equal. If this is the time interval t1, this is t2, then t1 and t2, which is called as t on and t off, they are equal, and if t on and t off are equal, then we can get a square wave. We have, in case of Astable multivibrators, which was constructed using op-amp. There are more applications, such as it can be used for analog frequency meters. We can make use of this in temperature measurement. So there are numerous applications where 555 timer can be used. It can be used for temperature measurement and control. So if we need an automatic control system, we can make use of IC 555. We can make use of this in fire alarm, burglar alarm, or ambulance siren by changing the duty cycle. So we can also make use of this as a voltage regulator. And as I have already emphasized earlier, we make use of traffic light. You can construct a project wherein you can control the timing of various LEDs. So you can develop a project where you can make use of various LEDs, and then you can control their timing according to a particular sequence defined by you. So what is IC 555? It is a monolithic IC. It is a monolithic circuit. I have told you the meaning of monolithic circuit. Monolithic circuit is a type of chip that is developed on a single wafer. Wafer is the base of a chip, of an integrated circuit, and it is responsible for generating. What is it responsible for generating? Can you answer this question? It is responsible for generating what? It is responsible for generating accurate time delays. This is the power of this IC, that it is always accurate. It has the same clock frequency, or we can also call this as oscillation. So it produces a waveform which is always having the same frequency and time period, right? So generally this IC is available as an 8-pin IC, and the type of package that is used is a metal can, or we can have a dual in package also, which is called as DIP, or we can have a 14-pin DIP also. So at present, the conventional IC 555 that we are using looks like this, that I am going to develop right now. So this is the chip. So it looks like. So on this side we have 4 pins. In the laboratory we have experiments which are based on obtaining the output frequency of IC 555 when it is used as an Astable multivibrator or as a monostable multivibrator. This is the notch here, right? And from here, this is pin number 1, 2, 3, 4. Then we go in the anti-clockwise sense, 5, 6, 7. Yeah. So this is pin number 6, pin number 7, pin number 8. This is IC 555. Is the screen visible to you, students? So the first pin is ground.
Yes, sir.
Then second is trigger. You know the role of trigger pin. What is the role of trigger? Where is trigger used? Output. Pin number 4, reset. Pin number 5, control voltage. Then pin number 6, threshold. Pin number 7 is discharge. We will discuss with an internal diagram how it looks like. Anybody can tell me where is the trigger pin used? We have discussed earlier. So this is the pin diagram of,
सर टाइमर है तो
yeah,
सर वो टाइमर है तो मतलब स्क्वायर वेव की तरह करेगा, तो प्लस वीसेट से माइनस वीसेट से प्लस वीसेट अगर उसमें होता है तो
ट्रिगर मैंने आपको बताया था. ट्रिगर पिन इज, trigger is used in case of, where is the trigger used? Trigger is used in case of which circuit? Which circuit is trigger used? Monostable multivibrator. If we are using IC 555 as a monostable multivibrator, then we make use of this pin called as trigger. Otherwise it is internally connected. If we use IC 555 as an astable multivibrator, then we don't make use of trigger pin, we connect it internally. But if IC 555 is used as a monostable multivibrator, in that case we are applying a pulse, we are applying a trigger pulse at pin number 3, right? Okay, now this is the IC number of pin. This is sometimes referred to as SE 555. SE stands for Signetics Corporation. It is designed at an operating temperature of, it can operate up to, the temperature range is minus 55 degrees centigrade to plus 125 degrees centigrade. You can imagine how efficient is the chip, right? Another version of this chip, which is NE by National Semiconductors, it is NE 555, that operates over a temperature range of 0 degree to 70 degrees centigrade, right? And it can operate on both voltages, plus 5 volts also we can use it, and the range can be from plus 5 volts to plus 18 volts supply voltage. So VCC, as mentioned here, as pin number 8 is VCC, you can see, and between okay, so here we have, on the input side we have circuit connected in this manner. So this is comparator 1, or let me call it as UC. C is for comparator. So we have two comparators that are connected here, and we will discuss the operation of these comparators. The output of these comparators serves as input to a flip-flop, which is RS flip-flop. And here is the voltage divider network. which is comprising of resistances which are connected in this manner. We have resistances which are connected like this. This is going to the ground. These are resistances of 5 kilo ohm each. Here also you have a 5 kilo ohm resistance, and this is connected to VCC on this side, right? Then the first comparator, we have the threshold pin. This is pin number 6, which is marked as threshold. You have to draw this in the exams. So this circuit is quite easy to understand. It is connected over here. Control rules of terminals are performing. Here the voltage developed is 1/3 VCC. The third pin, this is trigger pin here. As I was telling you, we can apply an external trigger here. This is trigger. Trigger is pin number 3. Here we can apply an external trigger like this if it has to be used as a monostable multivibrator. And the voltage, can you tell me the voltage here? What is the voltage developed here at this point? What is the voltage here?
Sir, 5 volt.
यहाँ पे कितनी वोल्टेज है इस जगह पे? आप ऐसे मान के चलिए कि 3 रेजिस्टेंसेस ऐसे लगे हुए हैं, R, R और R. R का मतलब यहाँ पे 5 किलो ओम रेजिस्टेंस लगा हुआ है. R, R एंड R. यहाँ पे वोल्टेज है VCC, राइट? तो इस जगह पे कितना वोल्टेज होगा? इस जगह पे कितना होगा? देखिए, अगर मैं इसको यहाँ पे इस पॉइंट को ए पॉइंट मार्क करता हूँ, तो ये आपका ए पॉइंट है. यहाँ पे व्हाट इज द वोल्टेज डेवलप्ड एट पॉइंट ए? एट दिस पॉइंट व्हाट इज VA एंड व्हाट इज VB? VA विल बी
लैग हो रही है.
VCC into 2R upon 3R. Are you getting this? VA का मतलब है voltage across this resistance, this network, the combination of R and R. So VA will be equal to total voltage VCC into 2R, because VA is the voltage across which thing? Across 2R, right? So 2R divided by total. So what is the voltage at VA then? This will be
VCC by.
So VB will be VCC into VB is the voltage across R. So it will be R upon 3R. So it will be 1/3 VCC as I have mentioned here. Can you see the voltage here marked as 1/3 VCC? So the 1/3 VCC. So this is UC1 upper comparator. UC का मतलब है upper comparator 1. This is upper comparator. This is lower comparator LC. So I can mark this as LC. This is lower comparator, and this is flip flop. Here the output of the flip flop is Q and Q bar. Out of this we are making use of Q bar. This is going to a discharge transistor. Transistor is connected in this manner. Here the base, the collector of the transistor is connected here, and this end you have to develop the circuit in this manner. Here we have a transistor which is a discharge transistor, which is connected in this manner. Now, what is the role of discharge terminal? I have we are going to discuss when we will put this circuit, when we will convert this into astable and monostable network. That time we are going to discuss it. Okay, now if we look here, this end of the block, so we can connect it here in this manner, and this end is connected here. This is the power amplifier, or it is the inverter circuit. It is a common emitter amplifier, and this is where we are getting the output. So if you look back into the chip configuration, output is pin number 3. So this is pin number 3 here. Discharge terminal is pin number 7. This is discharge here. Right? And here we are applying the reference voltage, V reference, and on this side we are applying the reset pulse. This is the reset transistor. You can mark this as Q2. So this is what is contained inside the chip. This is the inner circuit diagram or internal composition of the IC 555 chip. Right. Now we are going to discuss the function of various pins here. If time does not permit today, we can go in the next session. So as we can see here in the chip, we are making use of a voltage divider network in the form of 3 5 kilo ohm resistances, and we can make use of these resistances to distribute the voltages between upper comparator and lower comparator. So if we look at these comparators, these are the polarities. Now let us discuss the pin configurations. Pin 1, I have already told you, pin 1 is ground pin, followed by pin number 2, which is the trigger pin. What is the role of the trigger? I have discussed with you earlier. Role of the trigger is that the output of the timer depends upon amplitude of the external trigger pulse. Amplitude of the external trigger pulse applied to this pin. So if we apply a particular trigger to pin number 2, then the output will depend upon the shape or the amplitude of shape as well as the amplitude of the pulse which is applied to pin number 2, right? So whenever we apply a negative going pulse, as I can see here, if for example if I apply a negative pulse which has got amplitude larger than 1/3 VCC, so if I apply a pulse which is larger than 1/3 VCC, then what will happen? What will be the output of lower comparator here? Because the other end of the comparator is at 1/3 VCC. If I apply a pulse equal to or greater than 1/3 VCC, what will happen to the output of comparator 2, lower comparator? Will it go low or it will go high? Because comparator switches, yeah, exactly, because of the comparator voltage is, if I mark this voltage as V1 and I mark this voltage as V2, if I mark this as V1 and I mark this as V2, I'll again change this. Yeah, if I mark this voltage as V1 and I mark this as V2, if output is A times V1 minus V2, and if V2 becomes greater than V1, what will happen? VO will tend to negative saturation. So the output will go low. We can say low if we apply a pulse having amplitude greater than 1/3 VCC to pin number 3, right? Similarly, if the pulse applied to the threshold pin is greater than 2/3 VCC, then what will happen? Look at this diagram. If at the threshold the voltage applied is greater than 2/3 VCC, what will happen to the output here? Yes, what will happen to the output here? It will go high with the same logic, right? Okay, so we close the discussion here because we have approached the end of this session, and we can start with our discussion tomorrow. In tomorrow's session, we will study the operation of monostable multivibrator and stable multivibrator using internal pin configuration, internal pin diagram that we have drawn right now. Okay, so till that time, you can revise the concepts